Are you hearing me, Miss? Abu Zaid and Ahmed, are you hearing me?
Yes, I hear you.
How's everything?
That's good.
Okay. Do you see my screen?
Yes, doctor.
Yeah, it's clear.
Okay, so we are still in chapter 4. And during this lecture, our aim is to solve non-homogeneous ordinary differential equation. But these non-homogeneous differential equations, we will learn a new method to solve it. Before we go more in details through our lecture, let's recall what we discussed in the previous lecture. What was our main objective in the previous lecture? What did you explain in the previous lecture, Miss?
What
did we explain?
Method of undetermined coefficients.
Okay, so method of undetermined coefficients. Okay, who can give us an example? When can we use the undetermined coefficients?
When you have a non-homogeneous equation.
Okay, so I will write 2 equations and you will tell me whether we can use it. So let's say I have here y4 minus y cubed plus y prime equal ex minus x. In this case, can we use it?
Yes.
Oh, why? Because this part, the homogeneous part, is linear with constant coefficients, right?
Yes.
Okay. And this one that is here, the function g of x is divided into 2 parts. This one, it's exponential, so we are okay with it. And this one that is here is polynomial of degree 1, and we are also okay with it. So in this case, undetermined coefficients can be used, right?
Yes.
Noor, is it okay?
Yes, miss.
Okay. Now let's look at this example. If we have y double prime plus 9y equal tangent 3x. So let's look at this side. Are you okay with it?
Yes.
Okay. Linear with constant coefficients. Now let's look at this side. Are we okay with it?
I think we're only okay with the sine and cosine, right?
Exactly. So does it belong to the table?
No.
So we can't apply undetermined coefficients for this equation. Do we agree, Miss Ali?
Yes.
Yes, doctor.
Is it clear?
Yes, doctor.
Okay. Now let's look at this example. Are we able to apply the undetermined coefficients?
I think no, because it's not a constant.
Exactly. So this one is ODE, linear ODE with non-constant coefficients. How did we know non-constant coefficients? From x squared implies that we can't apply undetermined coefficients. So why do we need to learn a new method, miss? Already we have a method. Why should we learn a new method? Because this method, it has a limitation. It's just restricted for constant coefficients and for certain types of functions. So during this lecture, miss, in order to understand it, we need determinant and we need basic integration formulas. And our main objective is to apply our new method to a second order linear non-homogeneous ODE. Any questions before we start? Any questions, miss?
No.
We said here that we need determinant, and because we have second order differential equation, so basically we need just the determinant of a 2 by 2 matrix. So we will recall together what's the determinant of a 2 by 2 matrix. What's the determinant of this matrix?
AD minus BC.
Main diagonal minus second diagonal. Any questions before we start talking about our method, miss? Do we have any questions? And Noor, you sent me a message on Teams asking about something. Did you get the answer?
Yes, miss.
So our aim is that we will start with this differential equation. It's non-homogeneous. In order to solve it, first we need to solve the homogeneous one, find its answer. Our aim here is about the particular solution. So we need to write it in standard form. When we say standard form, it means that what we have here before y double prime, we need to get rid of. How do we get rid of this element, miss?
Divide by 2.
But divide by 2. We will solve the homogeneous ordinary differential equation, and then we will find the particular solution. The particular solution, if we look at the homogeneous ordinary differential equation, we should have two independent solutions. What are the two independent solutions? Y2 and Y1. Of course, we will find them. Let's say x and x squared, or ex and e negative x, let's say. We have them. The particular solution, it will be u1 y1 plus u2 y2. Our aim is to find u1 and u2 because the particular solution, it is a function without constants or without variables. Right, miss? Any questions till now? Are the steps clear so far, miss?
Yes.
The others, miss? Okay. Now, how to find u1 and u2? We can find first the derivative of u1 and the derivative of u2. How do you find derivative of u1 and u2? It is w1 over w. And U2 is W2 over W. But what's W? Do we still remember the Wronskian, miss? Wronskian.
Yes.
Okay, so what's the Wronskian, miss, here? The Wronskian is Y1, Y1 prime, Y2, Y2. Miss, we need W1. You will copy again. You will copy again what? The Wronskian. Then, because it's W1, we will remove the first column. This first column, instead of it, already we wrote this one in standard form, right? We have f of x on the right-hand side, so we will write here 0 f of x, and we will evaluate it. It's a determinant. Any idea how can we do W2, Abu Zaid? What do you think? W2, how can we do it?
We put y1, its derivative, and y2 we replace it by 0 f(x).
Yes. So we will copy again y1, y1 prime, because we have here W2. Instead of this one, we will put 0 f of x. Okay, miss? So we found W1, W2. U1, logically, it depends on W1, and U2, it depends on W2. So U1 is U1 prime is W1 over W, and U2 prime W2 over W. Miss, if we have U1 prime, U1, it will be integral of U1 prime. And U2, it will be integral of what? U2 prime. We found U1, U2. We will substitute in the particular solution and then get the general solution as homogeneous part plus particular solution. Miss, we will do these steps in details in the example so that you can understand it better. Would you like to start with an example and explain all these steps?
Doctor, I just have a question.
Yeah.
Don't we differentiate in the
No.
Wronskian from the first
No,
one to
the
the second one?
derivative is equal to this one. You don't need to differentiate because you don't have the function to differentiate it. We are saying that the derivative is equal to W1 over W. So you have U equal W1 over W, U1 prime. So you need to find U1 how you will integrate.
No, I mean the determinant when you're calculating the determinant.
Yeah, didn't I put the derivative as well? We put the derivative.
Yes, but how did 0 get into fx?
This one later on we will explain it in linear algebra in next lecture. This one, it looks like Kramer's rule.
That's the one.
Yeah, so W1 will copy again W, but instead of the first column, we will replace it as 0 f of x. Okay, miss? Okay, let's look at this example. What I need from you to do is just to copy this one and we will solve it in detail. For y double prime, let me just write it. So 4y double prime plus 36y equal cosecant 3x. Go back to the steps, write this one. We will go to the steps and do step by step. So step number 1, we need to write it in standard form.
Divide by 4.
Divide by 4. How did I know that we have to divide by 4? Smile. What will we get after we divide by 4? Smile, are you hearing us? Okay. Ahmad, what will we get? Ahmad al-Tayyib, what will we get after we divide by 4?
Y double prime plus 9y.
Equal?
1 by 4 cosecant 3x.
Now, this one, it will be our f of x, right? Right, miss?
Yes.
Okay. Noor, what's the homogeneous equation here? The associated homogeneous differential equation.
Is it y prime plus 9y equals to 0?
Okay, how do we solve this one? This one is from section
M squared plus 9y.
m squared plus 9y.
Sorry, plus 9, I guess. Yeah, plus 9 equals to
M
0.
squared plus 9 equals 0. M equal plus or minus 3i. And y is equal C1 cosine 3x plus C2 sine 3x. So let's go back to the first 2 steps. The first step is write standard form by dividing by what we have before y double prime. Identify your f. Step number 2, solve the homogeneous differential equation. Identify your y1 and your y2. So this one, it will be y1. One of them will be y1 and one of them will be y2. Is it clear?
Yes.
Any questions before we proceed, miss? Okay. So let's continue now. Step number 3, already we identified our y1 and y2. Find w. W is the Rauskin, and of course it will be not equal to 0. So y1 is cosine 3x, y2 is sine 3x. y1 prime, what's the derivative of cosine 3x?
Negative 3 sine 3x.
And Lu'ay, what's the negative of sine 3x?
Negative 3 sine 3x.
Sine 3x, it becomes?
Negative 3 sine 3x. Cosine. Cosine
3x.
Cosine. Sorry.
Okay, but is it negative or positive? The sign is positive.
What?
Sine 3x, it becomes 3 cosine 3x, right?
Yes.
Okay. So what will be the determinant here? 3 cosine square 3x minus, it means that plus 3 sine square 3x, which is equal to 3. How did we know that it's equal to 3? We can take here 3 in common. Sine square alpha plus sine square alpha is equal to 1. Right, miss? Are we okay with this one? We found this one before in section 4.1. Any questions, miss, before we proceed?
No.
Okay. Now we need to find W1. Again, W1, we will write again the Rauskin. And instead of this one, what should we put? 0 f of x. And what was f of x? One over 4 cosecant 3x, right, miss? Wasn't this one f of x?
Yes.
Okay. What's cosecant alpha? It's equal to what? And secant alpha is equal 1 over
Cosine.
cosine alpha. Find the determinant. Let's find W1. What will we get W1 as? 0
4.
minus 1 over 4 cosecant 3x sine 3x, right? Right, miss? Cosecant and sine, they cancel each other, so we will get W1 equal minus 1 over 4. Are all of us able to see that W1 is equal 1 over 4 minus 1 over 4, miss?
Yes.
The others,
Doctor,
miss?
Can you
Yeah.
go back to slide number 16? Okay, thank you.
So cosecant is 1 over sine. We can write it in this way. We found W1. Please, miss, find W2 now. Did we finish writing this slide, miss? W2, we will write again. And this column we'll put instead of it 0. What will be the determinant here, miss?
Cosine, I think.
Right, miss? Which is
Yes.
1 over
1 over 4
4
cosine.
cosine 3x. At this moment, I will keep it as this way.
Oh.
Sine 3x. Okay, so this one is W2. We'll put it in a box. Okay. Go back to the steps that we need to do. First of all, we wrote it in standard form. We identified our f of x. We found y1 and y2 that they are solutions for the homogeneous ODE. Then we found w, we found w1, we found w2. Now the next step is to apply the formulas, right? Find u1 prime and u2 prime. Any questions before we proceed, miss?
No, doctor.
Any questions? No. u1 prime is equal w1 over w, and u2 prime is equal w2 over w. What was w1, miss?
W1 was negative 1 over 4.
Negative 1 over 4 over w, it was 3, right?
Yes.
So we will get this one as negative 1 over 12. And W was 3. W2, it was 1/4 cosine 3x over sine 3x. We can write it as 1/12 cosine 3x over sine 3x. Do we have any questions about U1 prime and U2 prime? Any questions, Miss?
No.
No, doctor.
بس miss you missed the 1 for the 12.
Yeah, it's 1/12. U1, we said that it's integral of U1 prime, and U1 prime is negative 1/12. So integrate negative x over 12. Do we put constants, Miss? We don't put constants for U1 and U2. So this one is U1. Now U2 is integral of U2 prime, which is 1/12 cosine 3x over sine 3x. You can write it, Miss, as cotangent 3x, cotangent 3x if you want, okay? Do we have any questions so far? Do we have
Do you
any
need-
questions, Miss?
Do we need to know how to integrate cosine 3x over
Yeah,
sine
I will
3x?
integrate. We will integrate it. It's easy. We can integrate it the same way as tangent, which is using the substitution.
Mhm.
So U2 again, it's equal to 1/12 cosine 3x over sine 3x dx. Here we have two options, either to be memorizing the rule, or we can say let u equal sine 3x. We will get du equal 3 cosine 3x dx, and then we will get this answer. So U2, it will be 1/36 ln sine 3x. Of course, we need absolute value. So here the other method is to say let u equal sine 3x. du is 3 cosine 3x dx. We will get du over u, so ln absolute. Do we have any questions about U1 and U2, Miss? So this is step number 4. Any questions, Miss?
No.
Now, Miss, step number 5. U is equal, YP, the particular solution, is U1 Y1 plus U2 Y2, which is U1, we got it as negative x over 12. Y1, it was cosine, Miss, right? Cosine 3x plus U2, U2, it was 1/36
ln sine 3x.
multiplied by sine 3x. So this is YP. Now the last step that we need to do is we need to write Y as YH, the homogeneous part, plus the particular solution, and we need to write them. Do we have any questions, Miss? Do we have any questions?
No. Here, do we need to check for independencies?
No,
In the
because
while?
for sure they are independent, miss.
Mm. Okay.
The round scan is not equal to 0, and YP is designed in a way to be a party to be independent. So no need for the independency.
يعني
Do we
just
have
add
any
them up.
question? Yeah. To make sure that we understood, miss, this one is y double prime minus y equal to 1 over x. Let's discuss it together before I send you to the breakout rooms to check it and try to do the steps. Where's our problem here? Is it in the homogeneous part or in the function?
What is the
Abdurrahman?
function of problem?
Johnny is saying the problem in the function. What about Dilshad and Abdurrahman? Do we agree? The function, are we able to use the undetermined coefficient for it? Okay, so the first step of applying our method is to write in standard form. Isn't it written in standard form?
Yes.
Yes.
So what's our f of x, miss?
1 over x.
Yes. Please write the question so that I can send you to the breakout rooms, miss, to solve it. And I will enter each of the breakout rooms to check your progress in it. Did we write the question?
Yes.
Yes.
Okay, miss. So which room finished the work that was assigned? Are you seeing the screen, miss?
Yes.
Yes.
Okay. Now we need to identify our homogeneous and our f of x, right? What's our f of x here?
1 over x.
The homogeneous y double prime minus y equal to 0, right, miss?
Mhm.
So this is step number 1. We identified that. This step all of you were done with it. Step number 2, we need to solve on the auxiliary equation. And this one is our y1. This one is our y2. This step, did all of us make it correctly?
Yes.
Yes.
Now the step after it, we need to find the Ranskin. Ex, e minus x here, ex, e minus. So ex times e minus x minus
Shouldn't it be
ex times negative e minus x minus ex times e minus x. This one will get negative 1, which is negative 2. E power a and e power 0 is equal to what, miss?
1?
1. Did all of us get the Ranskin as negative 2?
Yes.
Okay, this is W, miss. What do we need to find after W? Please, if you are taking notes, I will keep the slide for 1 minute. Now, this is W. We need to find now W1 and W2. W1, we put 0, f of x. What was f of x? 1 over x, right? And here what do we have? E minus x, negative e minus x. We will get negative e minus x over x. This is W. Right, miss? Is it correct?
Yes,
Yes.
doctor.
Now what do we need after that? W2,
W2.
which is ex, 0,
1 over x.
0, 1 over x only, right? So we'll get ex over x. This is W2. So if we go back, we found W, W1, W2. Now the fourth step, U1 prime is equal to W1 over W, which is e minus x over 2x, right? And U2 prime is equal W2 over W, which is ex over x, and we have negative. So negative ex over 2x. This step, all of us did it correctly, miss?
Yes.
These integrals, miss, they are not like, we will not get an elementary function when we are integrating it. So because of that, they do not follow a rule that we learned. We keep them the same. Okay? And step number 6, we write y equal u1 multiplied by y1, which is ex, plus u2 multiplied by e minus x. And step number 7, we will write y equal yh plus yp. Okay, miss? We
So we
said
keep
if we still,
U1 and
yeah,
U2
you
the
will
same.
keep them, because even if you like try to use a solver, it will not give you the answer. These are not elementary functions. Like, we cannot get an elementary function. We know that it has an integral, but this integral, I cannot say that it's equal to this function that is like explicit function that we know. I need to write it in terms of series, in terms of special functions, or in terms of these ones. Is it clear, miss?
بس يعني in the exam you won't get us something like this. And there will be an answer for it.
I will keep it for you as a hint that you can keep it in terms of the integral. So you know that
Okay.
this one, we cannot find its integral.
Okay.
Do we have any questions, miss? Okay. Here we have some exercises. Now I want to make sure we already did this exercise as group. The next exercise that we will do is y double prime plus y equal tangent to x. So we'll start with this one now. And I need each of you to write this question and start with it. Please start with this question. Do all the steps that we did, miss. Okay, so if you look at the slides that I was working on while you were doing the independent work, I just wrote the steps. So what's the first step, miss? Identify our f of x and h. And this one we can identify it according to what? We can identify it by finding the standard form. Already the standard form is given. Step number two, we need to find y1 and y2, which are the solution of the homogeneous differential equation. Then we will find upper w, w1, w2, then u1 prime, which is equal to w1 over w, and u2 prime, which is w2 over w. Then we will find u1, which is integral u1 prime, u2, which is integral of u2 prime. Then we will find yp, u1 y1 plus u2 y2. And finally, we'll write our solution as y equal yh plus yp. Are you okay with the steps, miss?
Yes.
Which step did we reach? Shamus, which step did we reach? Dilshad? Miss, are you with us? If you are unable to unmute, just write in the chat.
Doctor, you are
Ahmed?
asking us which step we've reached or which step is on the screen.
Which step you reached?
Right now I'm now finding W1 over W.
Okay, you are finding U1 prime. Okay, Luay?
Yes, miss.
Yeah, which step did you reach?
I still didn't solve the question.
Okay. So let's solve it together. Half of x is equal to what, miss?
Tangent
Tangent
x.
x, and this one, y double prime plus y equal to 0. The first step, are we okay with it before we move to the next step?
Doctor, it's clear.
Doctor, you're muted if you're talking.
Yeah, now you're hearing me, miss? Weren't you hearing me before?
For step 2, no.
Okay, so step number 2, we need to solve the homogeneous system, the homogeneous equation. Now you're hearing, right? We find the auxiliary
Yes.
equation. Tan y equals C1 cosine x plus C2 sine x. Y1 is cosine and Y2 is sine. Are we okay before we move forward?
Yes.
The Ranskelness now, it is Y1 and here Y2. Derivative cosine. Derivative is negative sine and this one. So main diagonal minus the second diagonal. We will get cosine square x minus minus, we'll get it as plus, which is 1. So this is our top. Is it clear, miss? Clear?
Yes.
W1, miss, we will copy
Doctor,
again that. Yes. Yes,
in
miss?
step number 2, why don't we take it as cosine x and sine minus x?
Wouldn't it be the same?
Would it?
What's sine negative x? Negative sine x, right?
Yes.
And at the very end, you are writing the solution. It's a general solution, two-parameter solution. So you are multiplying it by a constant. Whether I wrote C2 sine x or I wrote it as negative C2 sine x, aren't they the same?
They are.
They are. Because of that, it's easier like to get rid of the negative
Okay.
because it will be absorbed by the constant. Did I answer your question, Ahmad?
Yes.
So we found W. Now we need to find W1. W1 we will put here. So the first row, the first column is, and the second one will keep it the same, which is, it was sine x cosine x, right? Which is negative sine x tangent. At this moment, I will keep it in this way without simplifying, okay? This is W1. W2, miss, we will copy it again. And here, zero, tangent x will get W2 equal cosine x tangent x.
You can simplify it and make it sine
Yes,
x, right?
yeah, I will simplify it. I will simplify it in the next step, and you can simplify it from now. Any questions, miss? Now, U1 is W1 over W. W is 1, so do I care about it? I will just write negative sine x tangent x over 1, which is negative sine x tangent. And this one, W2, it is cosine x tangent x over 1. Johnny is saying that let's write tangent x as sine x over cosine x and get rid of these cosine x provided that they are not 0. And we will get the answer as sine x. Any questions before we proceed, miss?
No, doctor.
Okay. Now we need to integrate. This one is the integral of negative sine x tangent x dx. And this one is the integral of sine x dx. We can start with the one that we want. So U2, what's the integral of sine x? What's the integral of sine x? Negative cosine x, right? Now we need the integral of this one. This one we need to like rewrite it in a better form in order to be able to find the integral. So what's tangent x, miss?
Sine over cosine.
So tangent x is sine x over cosine x. So can we write u1 as integral negative sine square x over cosine x dx? Can we write it in this way, miss?
Yes.
Now, we know that sine square x plus cosine square x equal to 1. So can we deduce that sine square x equal 1 minus cosine square x? Can we write it in this form?
Yes.
Yes.
u1 is equal negative 1 minus cosine square x over cosine x dx, right? The minus, we can put it inside. We will get cosine square x minus 1 over cosine x, and here dx. Any questions? Any questions so far, miss?
No.
So now u1, we have here cosine square x. Can we write it as cosine x minus 1 over cosine x, which is cosine x minus secant x? Look at it. Can we write it in this way, miss?
Yes.
So what would we get u1 as? u1 now, it's integral sine x minus secant x dx. What's the integral of cosine x?
Sine x.
Sine x. And this one from the table of integration, it's ln secant x plus tangent x. If you don't have it on the table of integration, please add it. Or I can write it here for you. Just a second. And if we have cosecant, any idea what would we get?
It
Minus.
was negative ln x cosecant x plus catan x.
So we got now u1, we got u2. We will substitute in the exam. In the exam, you shouldn't keep them just as u1 and u2. You should put the values or the functions, put them as functions, okay? You will write u1 and u2, and then y is equal to what? YH plus YP. So this one, u1, it's equal ln sine x
Minus ln secant x plus tan x
multiplied by
times
sine or cosine, cosine, right? Cosine x plus u2, what was u2? Minus cosine x multiplied by sine x. And then we will copy them again here. Do we have any questions, miss? Do we have any questions? Now, is it
no,
clear?
doctor. Yes, it is.
Guys who were struggling in at certain points, is it now clear? Miss, suppose that in the exam, Look at the integrals here. One of them is straightforward, U2, and one of them it needs some work. But suppose that I wasn't able to find the integral U1. It's okay. Just write U1 is integral for what? And just put it here as integral. You will not lose lots of points. So you will lose just the points for the integral, 0.5 points or 1 point only. Okay, miss?
Oh,
Would you like to try one more question? Would you like to try exercise number 6? Please try exercise
not?
number 6. Exercise number 6, I will not solve it. We will discuss it. I will check your answers. So do you prefer to solve it independently or you prefer to send you to the breakout rooms? Please, if you prefer independently, raise your hand. Okay, let's go ahead and solve it independently. Feel free to lower your hands now.
Which question, doctor?
6, miss. Why double prime? I will share it in the chat, miss. I shared it in the chat. Okay, miss, are we feeling comfortable solving it?
Yes.
Miss, we will have an extra solving session tomorrow at 2. It will be online. We can consider it as part 1 of the revision for the exam and in case you have questions. Okay, miss?
At which time it will start, miss?
At 2, miss.
Okay.
Doctor, I might not be able to make it tomorrow. It will be recorded, right?
Yeah, usually I record.
Okay,
And
thank you.
if you have certain questions, you can send them on Teams ahead of time and I will solve them during the solving session. The solving session, it's extra, like we are not explaining something new. It's for QAs. And if you don't have questions, I will be preparing some questions. Most of the time they are from previous examinations and we solve them together. If I want to explain something new in it, I will be letting you know that it's very important not to miss it. The question y double prime plus y equal. I think I screenshotted it.
Y double prime plus y equals secant x, secant square x.
Square x, yes. Already it's written in standard form. Of x is equal secant square x and homogeneous one is y double prime plus y equal to 0. Already we solved it in the previous, right? Right, miss?
Yes.
So directly we can put now what's y1 and what's y2. This is cosine x and this is sine x.
Sin x.
Already we solved it the same in the previous question. Now the w, also we solved it. W, it is, we got it as -1, right? W1, we will
No, I
put
think it's 1.
0 secant square x, and here we sine x, here
W is 1,
cosine.
Doctor.
Yes, miss?
Use 1.
It's 1. Okay. This is W1, and we will get in W1. What will we get in W1, miss? Minus sine x secant square x. So this is W1. W2, it will be what, miss?
Cosine x times secant square x.
It's cosine x here, negative sine x, 0, secant square x. We get W2 equal to sine x, secant square x. This one, still the step to reach it, miss?
Yes, Doctor.
Now we need to find U1 prime, which is W1 over W, and U2 prime, which is W2 over W. W1, it is negative sine x. Okay, secant square x, can I write it now as cosine square x?
Yes.
1 over cosine square x, right? And W2, it's equal to cosine x, again, over cosine square x, which is 1 over cosine x, which is secant x.
Secant.
Now the next step, U1 is integral of negative sine x over sine square x dx, and U2 is integral of secant x dx. Again, who would like to remind us about the integral of secant x?
Then secant x plus tan x.
Evaluate this integral, miss.
minus secant x.
Let 1 is minus secant. Let u equal cosine x. Du is equal negative sine x, right? So what would we get here? U1 is equal negative du over u squared, which is 1 over u. And u, we took it as cosine x. So we will get it perfect as secant. So we got now U1 and U2. What's the next step, miss? The step number 6. YP is U1 Y1 plus U2 Y2. U1 it was ln absolute secant x. No, U1 it was secant x, right? Multiplied by cosine x plus U2 it was these two terms, they are equal to what? 2, 1. Any questions, miss? Do we have questions? Guys, do we have questions?
No.
Okay, what's the last step now? Y is equal to what?
Yp plus YH.
Yp plus YH. So now the last step, and we need to write it, YH plus Yp. Okay, miss? Do we have any questions?
No.
Okay, so the aim of this, we are still in higher order differential equations. We consider the non-homogeneous part in which the undetermined coefficients doesn't work. So this method, we call it variation of parameter. In it, we need to find determinants. We are using it as Wronskian, and we need to find the antiderivative. I will share with you the files so that I don't forget. Files shared now. Do we have any questions, miss? Any questions?
No, doctor, everything is clear.
Okay. Let me just share another screen. Miss, regarding the assignment, it's due today. It will close, I think, at 11 p.m. And regarding our examination, it will not be next week. it will be the week after it, during class time. We will have hopefully tomorrow a solving session, and the week after it a solving session like QA for the exam. Now we have only one more section in chapter 4. The exam it covers chapter 3, which is only one section, and chapter 4. What's left in chapter 4? If we look at this one, we are still in higher order differential equation, but this one is Cauchy-Euler equation, it's called. If you still remember in the previous lectures, we were concerned with differential equations that they are with constant coefficients. What about if it's not with constant coefficients? We will consider the case when it is a Cauchy-Euler equation. So what we need to know is how can we determine whether a certain differential equation it is a Cauchy-Euler equation, and how can we solve it and find the general solution. So first we need to know only the form of Cauchy-Euler equation and the method of solution. Let's look at this one. Is the slide clear, miss? I mean, is it shown to you?
Yes.
I will highlight what we want. This one, miss. Okay, take a screenshot of it and check if you observed something. What do we have before each y or y prime or y double prime? We have x power, the same derivative, right, miss? Did we notice that?
Yes.
Okay, I'll just make sure that you're okay with it. I will give you an example. So look at this one, miss. X squared y double prime minus x y prime plus 7y equal to 0, let's say. What do we have here? Double prime. And here what do we have? X squared. And here what do we have? Prime. And here we have power 1. And before y, because as if it's power 0, we have x power 0, which is 1. So this one, what do we call it? Cauchy Euler equation of which degree?
Second degree?
Degree 2. Okay. Let's give another example. Let's look at this one. X cubed y let's look at this one. What do we have here? 3. What do we have here? 1. And
1.
here y we don't have x in it. So this one is what? Of which degree?
Third degree.
Third. And it is Cauchy Euler as well. Okay. Can you construct your own example, miss? Construct an example of Cauchy Euler equation of degree 4. Who would like to share his example? Who would like to share his example, miss?
I can share it if you want.
Yes, miss.
Okay, 5 x power of 4 y to the power of 4, yeah, plus x square y 2 and then equal 0.
Perfect. So this one is Cauchy Euler equation of which degree? Or if order,
Degree 4.
I have to say of order, okay. So I should fix here. Instead of degree, I should use order. Okay. Now, our main objective is not just to determine whether it's a Cauchy-Euler equation or not. Our main objective is to solve it. So how do we solve it? Do you still remember when we have constant coefficient, we start the solution, the trial solution as e power mx, and then we find the auxiliary equation. Here, instead of e power mx, we start with x power. Okay, miss? Any questions? Any questions, miss? So
No,
instead
doctor.
of e power mx, we'll start with xm. Then it's a solution. So if we substitute it in the differential equation, we will get the left equal to the right. So then we will substitute it. After substituting and expanding or simplifying or whatever, we will divide by x power m, and we do have the right to divide by it because it's not equal to 0. We'll get an auxiliary equation. This auxiliary equation, we will find the roots of it. And then, based on the roots, we will put our answers. Okay, I will give an example, direct example on this one, and then we will discuss the rules. Let's say that we have here x square y double prime minus x 2x y prime plus y equal to 0. So based on this one, we'll start with y equal x power m not 0, right? Then we'll find y prime, which is mx m minus 1, and y double prime, which is m into m minus 1 x m minus 1. And we will substitute. Can you please substitute them in the equation? What will we get when we substitute? X squared y double prime is m into m minus 1 x m minus 2. This is m minus 2. Minus 2x y prime. So mx m minus 1 plus x power m equal to 0. Now, if you look at x squared and x m minus 2, what does it give you? And x m minus 1, what do they give you? M into m minus 1 xm minus 2m xm plus xm equal to 0. Do we agree? Do we agree that we will get this one, miss?
Yes.
Now divide by x power m not equal to 0. What will we get? M into m minus 1 minus 2m plus 1 equal to 0. Expand m squared minus m minus 2m plus 1 equal to 0. It means that m squared minus 3m plus 1 equal to 0. And this one, it will be our auxiliary equation. Okay, miss? Then, this is the auxiliary equation. We will check the roots of it. Do we have any questions? And the roots, they will be summarized based on this one. Now, hopefully, miss, next lecture, we will explain these ones in details, and we will be done with chapter 4, hopefully on Tuesday. Do we have any questions, miss, for today?
Doctor, could you just go back?
Which slide, miss?
The solution.
Miss, it's not
Right.
solved yet. I'm just explaining what do we mean by auxiliary equation. I'm just explaining these steps that they are here. I'm just explaining them, but we did not continue solving because we did not find the solution yet. So this is how we start. Y equal xm, substitute, simplify, divide by x power m, get your auxiliary equation, and then find the solution of the roots of the auxiliary equation.
Will the
Next.
solution rules be the same as YH?
This one already, it's homogeneous. So it will be the YH, yes.
Yeah, okay.
Any questions, miss?
Doctor,
Miss,
how many attempts is today's homework?
one attempt.
Okay.
Yes. It covers, I think, just to 4.4, which is the undetermined coefficients. It doesn't cover this lecture. Okay, miss. Take care, miss, and I will see you virtually tomorrow and physically, hopefully, on Monday and Tuesday. Any questions before we stop recording and end the meeting?
No, thank you, miss.
No,
Okay, miss.
Dr.
Thank you.
Have a great day.
Thank you,
Bye.
Doctor.
Okay, bye, miss.